Okay, here we go. We have a bit of 3D trig going on here. And we know that M is the midpoint here of GH. And we want to find the size of the angle between the line MA and the plane ABCD. So we want to find, here's ABCD. And we want to find the line, the angle between the line and that plane. So here's this line, MA. And we want to find the angle between that plane. So what you're going to do is you're going to imagine drawing a perpendicular down to that plane. Okay, and you need to create right angle triangles every time you do this, otherwise you're finding the wrong angle. Because obviously loads of different angles you could find between this line and this plane, but you want the smallest one. The smallest one is by creating a perpendicular between the plane and that point. And you create the perpendicular between the plane and that point, you have the smallest angle here. So now we know what angle we are looking for, and you get 1 mark just for drawing what I've just drawn there. You get a mark for just that in the exam. Okay, we can go about and find the size of the angle. Now what we notice is we're given no lengths in this question. So you could either just decide to call this 1 and then just keep everything in ratio. You can call it x if you like. So this will then be a half x. And then we want to find that length there. So we want to know what this is here. So let's just draw that triangle out. And this is the trick to doing it, is drawing out all the correct triangles. So we're looking at x over 2 and we're looking at x. And we're looking at this question mark here. So the question mark obviously equals x squared plus x over 2 all squared. So add that together and that gives me a quarter x squared. So we've got 1x squared plus a quarter x squared is 5x squared over 4. You're going to need to be, I'll just write that all out so you can see it all happening. So you've got x squared, that can be written as 4x squared over 4 because it's the same as 1x squared. X squared over 4, add these together, you get 5 lots of x squared over 4. So that's what that question mark is there. Now what we've got here is we've got, this is going to be equal to the, so if we want to find out what the actual, sorry, that was the square root, the question mark squared, and that's a question mark squared, and we want to, there's our thing, so we want to square root all of that. So we get the square root of 5, square root of x, and we get the square root of 4, which is 2. Now we now know this length here, and we're going to now draw out this triangle here, AM, and this point down here. I'm going to call this, what letter have we not got on here? Let's call it Z, okay, just to make sure it's a letter we don't have. So we're going to draw a triangle of A, M, and Z. We now know that this is root 5 over 2x, and we know that this is also x high because it's a cube, and we want to know this angle here. So we know that tan theta is equal to that side over that side. So we've got x divided by root 5 to x. So if we were to write that as a fraction, we turn it upside down and multiply. So we times by the 2's on the bottom and the root 5 and the x was on the top, so we put them on the bottom. And we can see we can cancel down x, so tan theta is equal to 2 over the square root of 5, and this is where we reach for our calculator. So I'll just grab my calculator, make it a bit bigger, just give me a second. There we go, so it's nice and big on the screen. And we're going to do 2 divided by the square root of 5, put that in. And I'm going to do inverse tan of the answer. And I get 41.81 degrees. And it says to 1 decimal place, so 41.8. So you notice I didn't worry about the fact I wasn't given any lengths. I just knew when I got to the tan, or at least hoped. You don't necessarily need to know. You're just going to hope that the x is going to cancel at some point. Alternatively, you could just think, okay, well, this is a cube. If it was 1 by 1 by 1, it would be exactly the same as 2 by 2 by 2 in the angles. Remember, when you enlarge a cube, all the angles stay the same. So therefore it didn't matter what size cube you chose. So you could have chosen any cube of any size and used the numbers instead of x's to do this question. And it all worked out nicely because angles under enlargement do not change. Okay, so there you go. There you have that question. Just remember, the key thing is to visualize the triangle you need and to create these drop-down right angles to create the minimum angle so you know which angle to find.